Welcome back to our channel. Today we are going to discuss about the complex numbers in an AC circuit. So what is the importance of this complex number? So generally complex numbers plays a major role in analyzing an AC circuit. Okay. So generally how we are going to represent a complex number, okay, is this can be of three types. Okay. A complex number can be represented in rectangular form. Second one is it can be represented in polar form, and it can be represented in exponential form. So in rectangular form, the representation we are going to write down this as a plus ib, where a is called as real part of the complex number and b is called imaginary part of the number. This same number in polar form we can write down it as r at an angle theta, or we can write down it as r. This can be written as cos theta plus j sin theta also, and the same can be represented in one more form where this is called r into e to the power j theta. You may get doubt here, what is the value of r and theta, where r is called as a real number. How to write down the real number r? R is equal to square root of a square plus b square, and theta is equal to tan inverse of imaginary part divided by real part. So this you can write down theta is equal to tan inverse of b by a. So here these are in degrees, or this we are going to write on it as phi, where phi is in radians. This is very important while you convert. So these are in degrees, these are in radians. So how to convert a degree into radian we will discuss later. Okay, so we have the formula 2 pi dig 2 pi radians is equal to 360 degree. So we need to require 1 degree. So 2 ones are 2 180 degrees. So therefore how I can convert is 1 degree can be represented as pi divided by 180 degrees. The resultant when you multiply this will be in terms of radians. Okay. So this is how to convert a degree into an radian. Let's try to see some problems how it plays an major role. So what is the importance of this complex number in AC circuit analysis means? So generally in a DC supply we generally call as resistance, inductance as well as capacitance. So here the units we are going to represent it as R ohms, this in terms of Henry, this in terms of as farads. So this in the case of an DC supply. In the case of an AC supply, we are going to write down this R, this as plus j x l ohms, this as minus j xc ohms. This we can also write down in S domain. It's also the same domain. S domain means frequency domain. Why? Because S is equal to j omega, where omega is also called as j into 2 pi f, where this is also called frequency domain. So here in this frequency domain also we can write down this as R ohms. This we can write down it as SL ohms, and we can write it as 1 by SC ohms. So this is very, very important. So here the impedance, how to write down the impedance. So here all are in henries and farads, exactly how to write down. Here the impedance we can write down it as Z is equal to, with the combination of R and L, as R plus J XL ohms. Okay, so we have to write down it as R plus J XL ohms. So R plus JXL we can write down when it is a combination of R and L, or you can write down it as is equal to R minus J XC ohms. So R minus J XC ohms. So this is with you have resistor and inductor. When you have resistor and capacitive, this is also called. So here now what you have to understand is what is this XL. XL is called inductive reactance. XL is called inductive reactance. It is written as plus J XL ohms, and this also be written as plus J XL can be written as omega L ohms, and where this can also be written as plus J 2 pi 2 pi FL ohms. I mean, whenever this L is in Henry, whenever the Henry you are multiplying with 2 pi f, the ultimate units are transformed into ohms. Okay, so this is the importance of inductive reactance. And coming to the next one, which is called as minus JXC. This is called capacitive reactance. What is capacitive reactance? Capacitive reactance you can write down it as minus J XC ohms. So this we can write down it as minus J. XC can be written as 1 by omega C ohms. This can be written as minus J 1 by 2 pi F C ohms. So here what you have to understand is this capacitance is in farad. So when you multiply this farad into 2 pi f and you put a negative symbol, then automatically the units of this is ohms. That's what the importance of the conversion. Okay, so this is how to represent all the parameters as R plus JXL, R minus JXC ohms, where XL is called inductive reactance and XC is called capacitive reactance. Okay. So now you may get a doubt, sir, what is the difference here? So here also you can write down in the same format. So this is SL ohms. SL means you can write down it as J omega L ohms, which is also same. This can be written as plus X omega L is nothing but XL ohms. You can see here all are same, but representation is different. So this you can write down it. That's why I'm writing this as plus J XL ohms. You may get a doubt why I written as a plus J. This is what the formula, how I got plus J XL ohms. So here in this format, when you see here, this can be written as 1 by S is equal to, you already know that S is equal to J omega. So this can be written as J omega C, ultimate units are ohms. But I want to shift the J to the numerator. I am writing an operator. So since we have J square, I mean minus J square is equal to 1. Okay, so minus J square divided by J into omega C. Omega omega will get cancelled. This is minus J divided by omega C. This can be written as minus J 1 by omega C. So minus omega C is nothing but XC ohms. That's why I have been written in this format here. So hope you are able to understand. In the DC supply, we directly write down resistance and inductance in Henry and Farad. When you are writing in AC supply, we have to write down R ohms plus JXL ohms minus JXC ohms. In S domain, we are writing it as R ohm, SL ohm 1 by SC ohms. This is very, very, very important. If you understand this logic, You can play football with this kind of AC network analysis. So there are three types of complex number: rectangular form, polar form, and exponential form. Rectangular means a plus ib form, polar means r comma theta, exponential means r at an angle phi. So here theta is in degrees and here phi is in radians. This is what the conversion formula. Let us try to solve some few problems, then you can understand better. Okay, let's try to take, I have an complex number. Okay, so let's try to write down one complex number in a is equal to 1 plus j2. So this is in a plus ib form. This already I disclosed. So how to represent this? Okay, so this is in the form a plus ib. So now here this is a, I have a number that is represented as 1 plus j2. So a I have as 1 plus j2. So and I'm taking b as 2 plus j3. Okay, so this can also be written in the form of r comma theta as r is equal to root of 1 square plus 2 square, and theta is equal to tan inverse of imaginary part is 2 divided by 1. Okay, so 2 divided by 1. So this I can write down it as, so root of 1 square plus 2 square. So this is nothing but 4 plus 1, 5. This is nothing but you are going to get this values as root 5. Root 5 is 2.23 at an angle of 70 degrees. This is nothing but in degrees. So this how we converted. So this also we want to represent in the form of r at an angle theta, where this is the polar form. In polar form you can write down this r is equal to root of 2 square plus 3 square, and theta is equal to tan inverse of imaginary part. Imaginary part is 3 by 2. So this you can write down it as root of 2 square plus 3 square. 3 square is 9, 9 plus 4, which is nothing but root 13. So root 13, tan inverse of 3 by 2 is 62 divided 0.5 degrees. So here the imaginary form is 3.6 into at an angle of 62.56. So now this is one way of representation, writing in a plus ib form and writing in polar form. This is rectangular form and this is polar representation. Now what we can do now? Okay, so now this is one way of representation, and one more way of representation, let's try to see here. So here we can, this is basically a rectangular form, this is polar form. Now we are going to write down the exponential form. Exponential form. So here the exponential is r e to the power j 5. So r is how much now? 2.23, doesn't changes. E to the power j 5. So how to write down the phi is very important. Okay, so here phi is in radians. So as already I discussed how to convert a degree, already told how to convert and degree into radian. Okay, so now let's try to apply that formula here. So already I told 2 pi radians is equal to 360 degrees. So 1 degree can be represented as multiplying with pi by 180. So here already we got 70 degrees. So this is 70 degrees, but I don't want in degrees. The 70 degree is nothing but 1 degree. I'm going to write down as pi by 180. So automatically degree will get cancelled, and ultimate units you are going to get it in radian. So here the radian value is, so if you perform this 70 into pi divided by 180, you are going to get it as 1.22 radians. So this is 1.22. The ultimate units here are radians. So this we are going to write down in this form. So this is already 3.6 e to the power j. So how to write down the 5 here? So here 5 we can write down this as 62.56 degrees. 62.56 degrees. So 1 degree I can write down. 1 degree means I want to convert this degree into radian. So 1 degree can be written as pi by 180 degrees. So try to perform the multiplication. When you perform the multiplication, then you are going to get, so just you can use your scientific calculator and you can perform the multiplication. This is 62.56 into pi divided by 180. Then you are going to get it as 1.09. Ultimate units are radian. Why? Degrees will get cancelled out and automatically multiplied. The units of pi is radian. So here you are going to get 1.09 radian. Okay, so that is how to represent multiple parameters in three forms. Okay. So how to represent all the parameters in three forms. So these are in rectangular form, and these are in polar form, and these are in exponential form. Okay, so this is how the original conversion is happening. Now let's try to perform some multiplication between these two will help us to understanding multiple concepts. Okay, let's try to take this only as reference and let's try to perform. So between these numbers, let's try to perform. So generally this complex number, so complex number addition. Okay, so complex number addition and subtraction. It's very simple. Just we can add and subtract. I mean complex numbers means here in which category we come is, so rectangular form. If they are in rectangular form, you can perform addition and subtraction. Let's try to check out here how to perform it. So I'm defining a variable. I want a plus, I mean a variable a plus b I want to perform. So here a I can write down it as 1 plus j2 plus b I can write down it as 2 plus j3. Okay, so here how I'm performing the addition, you can have a look. So now this you can write down it as 1 plus 2 is 3 plus j into 2 plus 3 is 5. This is nothing but 3 plus j5. Okay, so you can perform directly the addition. And coming to the subtraction, a minus b. So how to write down this? 1 plus j2 minus 2 plus j3. So this we can write down it as 1 plus j2 minus 2 minus j3. So this you can write down it as minus 1 plus j 2 minus 3. This is minus 1 minus j1. So here you can write down, this is ultimate form. This is the sum of complex number which are in rectangular form. In rectangular form, you can perform addition as well as the subtraction. So this is 3 plus j5 ohm. This is minus 1 plus j5. So this is directly we can perform. Okay. So now similarly, we are going to learn how to perform uh, complex numbers multiplication as well as division. So we need to learn about multiplication as well as the division. Okay, let's try to check out here multiplication as well as the division. So here I am defining, I want an variable a into b. So that a can be written as, so this should not be in a plus ib form. So in complex number, if you want to perform multiplication, this should be only in polar form. Okay, so in polar form, how we can write down, this is 2.23 at an angle 70 multiplied with, what is the polar form of this representation, 3.6 at an angle of 62.56. Okay, so when you perform the multiplication, the product of these two, so open your calculators and try to perform the multiplication. This is 2.23 into 3.6. So this is 8.028, and the angles become added. So 70 plus 62.56. So this is 8.028 at an angle of 70 plus 62.56, so which is 132 degrees. Okay, so in complex number, we have been performed addition, subtraction as well as multiplication. In the same complex number, that if you want to perform multiplication or if you want to perform division, that should be in polar form. Now I want an answer of a by b. So a value is 2.23 at an angle 70 divided by b value is 3.6 at an angle 62.56. So this we can write down. So we can cancel out this value. Okay, 2.23 divided by 3.6, the answer is 0.619 at an angle. Here you can to subtract the angle 70 minus 62.56. Okay, so this is 0.619 at an angle of 70 minus 62.56, which is 7.44. So hope you got the complete clarity on these numbers. Okay, so complex numbers, we can perform the addition only when that should be in which form, rectangle form. In complex number, we can perform the multiplication and division, that should be in which form, polar form. Then only we can, so you can see here, this is also resultant r at an angle theta. This is also r at an angle theta. This is the real number, this is the other form, real part and imaginary part. This is of real part and imaginary part. Okay, so complex number, we can perform addition and subtraction. This should be in rectangular form. In polar form, it should be in multiplication and division. So these are all the variants. So there are three ways of representation. One is rectangular, polar and exponential. This is how to convert one number to another different form. So this is all about a complex number and how complex number make our analysis as easy. So hope you understand all the things very clear. And if you are watching the channel for the first time, please like the channel and please share with your friends. And if you have any doubts, let me know in comment section. And if you're watching for the first time, please subscribe the channel. This is a free channel for the betterment of students, which will help them to grow. So thank you for watching. Yours obediently, Rom. Will meet in the next problems on jet parameters. Thank you for watching.